So just as with distance, that we have centimetres, metres and millimetres, which are our metric units, and then we have our imperial units where we have inches, yard, feet, etc. The same is true with angles. We don't just have degrees, we have something called the radian, and there's the definition of 1 radian. So if we look at the circumference of this, we'll be able to see the link between the radian and the degree, because for every 1 unit travelled, we've travelled 1 radian. Well, using circumference is pi times diameter, then in total there is 2 pi radians in a circle, which we know is the same as 360 degrees. So therefore pi radians is equal to 180 degrees. That I think is useful. However, if I want 1 radian, it will be the same as 180 divided by pi. So 180 divided by pi, 1 radian is the same as roughly 57.3 degrees, rounded off. So using that knowledge that pi radians is the same as 180 degrees, or vice versa, then to work out 1 radian I said was 180 degrees divided by pi. Well, the same is true the other way around, that 1 degree would be the same as pi divided by 180. And like with the unity method, once you know what 1 is, you can work out 2 or 3 or 4 by just timesing by that value. Hence, to work out 135 degrees, I just times that by 135. So we have 135 times by pi divided by 180 equals 3/4 pi, which is useful for work in A-level trigonometry, or, because you're new to it, as a decimal 2.36 rounded off radians. The same is true for radians. If we know what 1 radian is, to work out any quantity of radians, we times by what 1 is worth. So 2.7 times by 180 divided by pi, out comes 154.7 degrees rounded off. Now, questions that we've looked at in the past for sine rule, cosine rule, etc. can be answered when the angle is given in radians instead of degrees. However, what you must make sure is that your calculator is adjusted. So you probably can't see this anyway, but on your calculators you have a D for degrees. If you press the shift and the setup, it brings up a display, and you'll see that number 3 on the Casios says degrees, number 4 says rad, which is for radians. So you press 4, I've now set this calculator in radian mode. So therefore I can do exactly what I was doing before for previous lessons on sine rule, cosine rule, but my calculator is now in radian mode. With this being taught, you need to make sure now though that your calculator is in the correct mode for the correct question. So if that's in degrees, the calculator needs to be in degrees. If that's in radian, your calculator is set in radians. So what we've got to find the length of x, which means with 1 angle mentioned, it is the cosine rule. So x squared is equal to 5 squared, add 7 squared, take 2 times 5 times 7, times by the cosine of 0.6. And if we throw that into calculator, because I have altered the mode to radians, it should be fine. 5 squared plus 7 squared, take 2 times 5 times 7 times cos 0.6, comes out as 16.2, etc. So therefore x is the square root of that, which is 4.0 to 1 decimal place. To find the area, we use a half of a times b times the sine of the angle, and once again, because I've already put my calculator into radian mode, I should be fine typing that in. So a half times 5 times 7 times the sine of 0.6 equals, and I get 9.88 or 9.9 if I'm sticking to one decimal place. Now where radians comes into its element is in, as I've shown here, arc length and area of a sector. At GCSE, you would have worked out the arc length by saying that the arc length is equal to pi times the diameter times by the angle divided by 360 degrees. And that's how you would have tackled it at GCSE. However, we now know that 360 degrees is the same as 2 pi radians. So if that angle is in radians, you wouldn't be dividing by 360, you'd be dividing by 2 pi. Well, straight away, that pi cancels with that pi. The diameter, however, can be written as twice the radius, and that 2 can cancel with that 2, and that's why the formula is that arc length, L, is equal to the radius times the angle. And that formula is fine as long as that angle is in radians because, well, you've seen we cancel it. The same is true for area, very similar proof for area. At GCSE, to work out the area of a sector, you would start with pi r squared, the area of the full circle, and then you'd times by that angle divided by 360 degrees. Repeating myself, if that angle is in radians, you would not be dividing by 360, you'd be dividing by 2 pi. Once again, that cancels. The 2 don't cancel this time. So you've got r squared times theta divided by 2, which they write as a half r squared theta. And again, that formula is only acceptable provided you're in radians. So there's the proof, but they're the only 2 things you have to remember. So using our new found formulae, we've got the radius of a sector is 4, and the arc length is 3. So it says, first of all, find the angle. Well, if I quote the formula, arc length equals r times theta. We're told that the radius is 4. We're told that the arc length is 3. So therefore the angle must be, take that across, divide 4, so we get 3/4. And that's in radians. Number 2, to work out the area of the sector, we quote the formula, a half r squared theta. So that's a half of 4 squared times 3/4. We could use a calculator or just witness that one of those 4's cancels. So you've got 3 times 4 and halved, so you've got 6. So this question is taught in trigonometry for questions like this, for reasons of questions like this. So we've been given this diagram. We're told that the radius is 4, and we're told that the perimeter of the sector is 10. So therefore we have got that 4 and 4 makes 8, so the part there is 2. So quoting the formula, length equals r times theta. 2 is equal to 4 times theta, which means that the angle must be a half, very similar to the last example. Now it says find the area of the shaded region. Well, I can find the area of the sector, so the area is going to be a half times the radius squared times theta. Calculator or otherwise comes out as 4. But all I found there is I found the area of the entire sector. To find the area of the triangle, I use a half AB sine C. Now my calculator is still set in radian mode, so therefore I'm fine to just type that in. A half times 4 times 4 times the sine of a half equals 3.83, etc. So therefore the area shaded would equal the 4 take that, which works out to be 0.165 to 3 decimal places.